everybody, and welcome to the Bioenergetics of Mixed Martial Arts. I'm Dr. Jason Gillis. We're still new in this course, so I want to give you an overview. In this session, we're going to talk about energy expenditure. In the next session, we're going to talk about the ATP PCR system, which it's responsible for powering high intensity efforts in the cage, like takedown attempts. Session 3, we're going to talk about anaerobic glycolysis, which really helps out during sustained high intensity efforts. But by far and away the most important energy system, it's aerobic metabolism. And we're going to talk about that one in session 4. And then in sessions 5 and 6, we're going to talk about maximal aerobic fitness and your anaerobic threshold. And both of those things have a pretty big influence on your performance in the cage, so I want to tell you about them. In session number 7, we're going to compare high intensity and low intensity training. I'm going to tell you which one is better. In session number 8, we're going to teach you exactly how you train an energy system. We're going to give you the workouts and everything. In session number 9, we're going to talk about how you structure your fight plan. And then finally in session number 10, I'm going to tell you, in my opinion, what I think is the best way to develop endurance in mixed martial arts. But let's get to session 1, the essentials of energy expenditure. I've got some learning objectives for you. I want you to understand how food is converted into energy. I want you to be able to describe how energy is stored in the body. I want you to define ATP, and that's adenosine triphosphate. I want you to identify how ATP is produced, and then I want you to describe how the energy systems coordinate to produce it. This is exactly what we're going to cover. This is the outline. First, we're going to talk about energy coming from food, and then we're going to tell you how it's all about ATP. We're going to define it, let you know everything about it. We're going to link in ATP to muscle contraction after that, and then we're going to tell you how to generate more ATP, how you can generate more ATP through energy systems. And we're going to emphasize the fact that all energy systems work together. So let's get into it. The basics of energy metabolism. Energy comes from the food that we eat. When you eat a meal, it's going to contain probably protein, carbohydrates, and fat. And the protein is going to get broken down into amino acids. The carbohydrates, it's going to get broken down into glucose, and that can be stored as glycogen in the liver and then in the muscle as well. And then when you have the fat, that's going to be broken down into what are called triglycerides. It's when you have a glycerol head in this molecule and a couple fatty acid chains. So all of these substrates, we can call them, amino acids, glucose, glycogen, and then fatty acids, they're all broken down further to create all sorts of energy. And that energy is going to be used to power muscle contraction. So normally the way we do this here, the way I like to do things is I tell you what I want you to know and then I show you what I want you to know. And so that's what this figure is. It's really just, I guess, a schematic describing what we just talked about. So you eat food and it's going to be containing most probably fats composed of triglycerides, carbohydrates, and proteins. When we eat fats, it's going to be broken down into free fatty acids and also this glycerol head, but we're going to be primarily concerned with free fatty acids. Carbohydrates are going to get broken down into glucose, and protein is going to get broken down into amino acids. So this is a critical point. When you have that meal, fat's going to be broken down into free fatty acids, and some of those are going to be free floating into what's called a free fatty acid pool. So think of it as your blood, fat molecules, free fatty acids floating around in your blood. But then some of it is going to be stored as fat, white adipose tissue under your skin. Similarly, when you eat carbohydrates, they're going to be broken down into glucose, which can float around in your blood, for example, in this glucose pool, but they can also be stored as glycogen in the liver or in the muscles. And then protein, when you have that steak or the chicken or whatever, it's broken down into amino acids. And just like you have glucose and free fatty acids floating around in a pool, you also have amino acids floating around in a pool. But if you have enough of them, and ultimately what you want to happen are those amino acids to be converted and stored as body protein. So the free fatty acid pool, the glucose pool, and the amino acid pool, they're all used for metabolism. That's to generate energy. Now let me just say that amino acids, our body doesn't like to use those, and really we only use those in a worst case scenario, like in a starvation situation. So amino acids, they really are not a big factor to metabolism. But what we want to be able to do then is we've got all these stores, we got fat stores, we got glycogen stores, and we got body protein stores. We want to be able to convert those into the pool so we can use them for metabolism. And there's a whole bunch of different mechanisms to describe that conversion, and the conversion from your fat stores to free fatty acid pool is called lipolysis. Now that name, it should hopefully sound a little intuitive because lipo is fat and lysis means breaking it down. So lipolysis means breaking down your fat stores so they float in the free fatty acid pool. But you can also go the other way. You can convert your free fatty acid pool into fat stores, and that's called lipogenesis. Lipo means fat, and genesis means the creation of new. So we have lipolysis going from fat stores to the fatty acid pool, and then we have lipogenesis going from the free fatty acid pool to fat stores. We can also create fat stores from glucose. So if you have a big glucose-based meal, then a lot of those carbohydrates, the glucose molecules, are going to be converted into fat and stored as fat. And that's another process referred to as lipogenesis. That's why it's not good to overeat carbohydrates. And now we're looking at carbohydrates and glucose. Now we can convert glycogen stores to glucose in a process called glycogenolysis. Glycogen is glycogen, and then olysis or lysis is breaking that glycogen down. So we can go from glycogen in the liver or glycogen in the muscle to a glucose pool. But then we can go back to glycogen as well in a process called glycogenesis. And we can also go from the amino acid pool back to the glucose pool as well in this process called gluconeogenesis. Now the big difference in this term is the neo bit, and that just means you're creating new. So gluconeogenesis means you're creating new glucose when there wasn't before. And now we're looking over at the far right of this video here. We're going from body protein to amino acid pool, and this is really not something you want to do. This is catabolism. This is breaking down your muscle. That's protein breakdown. We want to be going the other way. We want to be moving from the amino acid pool to body protein, and that's protein synthesis. So that's a little schematic that I hope describes the process of going from energy, from the food you eat, to the energy that we actually need to move our bodies. Now remember, I said it's all about the ATP. ATP, it's adenosine triphosphate. So you've got one adenosine molecule and then 3 phosphate molecules attached to that. When you break this adenosine triphosphate molecule apart, it's like an explosion. Energy is released. And really what's happening is where you're breaking that ATP molecule apart, it's the 3rd phosphate bond. So you're still left with 2 phosphates after you break it apart. So first it's adenosine triphosphate with 3 phosphates and 1 adenosine molecule. Break it apart, and then you're only left with 2 phosphates, or adenosine diphosphate. And like I said, that process releases energy, and that energy is used for muscle contraction. So you may be thinking, great, energy comes from ATP. But let me tell you, the stores of ATP in the body, they're not unlimited. There's only a finite amount of it. In fact, there's only enough ATP in the body just to allow for a normal person to function for just a couple seconds. After that, you die. So we need to find a way to generate new ATP. But let's just give you a little picture so you know exactly what we're talking about here with ATP. Because ATP, it's really important for muscle contraction. And I want you to link it in your head that ATP is there to power muscle contraction. So here's an example of an ATP molecule, one adenosine molecule with 3 phosphates. And what happens is when we need to provide for muscle contraction, then that ATP molecule, it will be broken apart. And we'll lose that phosphate, that inorganic phosphate, and energy is released in the process. And that energy that's released is used to power muscle contraction. There's my horrible little diagram. You can see that's muscles contracting. And then you're no longer left with ATP, you're left with ADP. So I hope you understand this process just a little bit, whereby ATP is required to create energy for muscle contraction, and then you're left with ADP. So you don't have ATP anymore. So we need to find a way to regenerate ATP after it's gone back down to ADP. So how do we do that? Well, ATP, it's regenerated a couple different ways that we're going to talk about in this course. 2 are anaerobic and 1 is aerobic. The 2 anaerobic ways that ATP is regenerated, it's 1 with the ATP PCR system, and 2 through a process called anaerobic glycolysis. And then ATP can also be generated through aerobic energy systems, and we're going to talk about all these in the next couple sessions. So the other thing that I wanted to mention is some people think of all these energy systems as working independently. You know, one turns off, the other one turns on. But it's not that way. They all work together. And we're going to talk a little bit more about that. I'm going to give you an example. But first, I just want to give you a little schematic overview here. So what we're looking at on the top of this slide, it's ATP. And there's really two ways we can regenerate that ATP. One is with anaerobic glycolysis, and the other one is with aerobic energy systems. We can generate more ATP. The other system, I like to classify it as a system that allows you to go from ADP to ATP. And the system that's responsible for that, it's adenosine, or it's the ATP PCR system. So we're going to talk about all these energy systems in the next couple sections, and hopefully it'll become more clear as time goes on. So I want to give you a little example of energy systems working together, because it's not just one. What we're looking at here on the vertical scale is the percent contribution to the total ATP supply in your body, and it ranges from 0 to 100%. And so let's say that you're performing a 6-second effort in the cage, like you're going for a takedown, so you're really pushing for it, and it's going to take you a couple seconds to complete it. About half of the energy is coming from the ATP PCR system, so that's important for these explosive movements. And the other half of the energy, it's coming from anaerobic glycolysis, and then there's a small amount of energy coming from the aerobic energy systems. Now, if you were to perform a 30-second effort, and remember, a round in MMA is 5 minutes, and a whole fight, it can be 15 minutes to 25 minutes, depending upon if it's a title fight. So by the time you get to a 30-second effort, and we've all been there, where you're grinding someone out, or you're getting grinded out on the fence, or you're trying to move, and it's a sustained effort for 30 seconds. In that case, look what happens to the total contribution of ATP supply from the different energy systems. Notice the ATP PCR system, it's only contributing about 17% of the total ATP supply. Also notice that anaerobic glycolysis is still producing a lot, but it really didn't change very much from the 6-second effort, did it? Now, the big change here, it's with the aerobic energy systems. The aerobic energy systems are really stepping up to power this 30-second effort. Now, as you go on over the course of the fight, I'm going to tell you right now, the aerobic contribution to the total ATP supply, it just shoots up. So the point that I want you to understand here is the aerobic energy metabolism, it's really the most important metabolism. It's really the most important energy system for producing ATP in MMA. So here's a summary. Number 1, food is converted into energy. Number 2, energy is stored in the body as ATP. Number 3, ATP is produced by aerobic and anaerobic energy systems. And number 4, energy systems coordinate together to produce ATP. Here are a couple references if you want to go on to read a little bit more. By all means, dig into it. But other than that, that's it for this first session. I just wanted to get in, just give you a couple things to think about, and hit you with that take-home message, and get you set up for the next couple lectures, which are going to be on energy expenditure and bioenergetics. So that's it for this lecture, and I look forward to seeing you in the next one. Take care.